Good morning, class. Welcome to the online classes of physics for class 9th. In the previous classes, we have said that we are going to start the revision for the chapter 2, that is force and the laws of motion. In the last session, you may have seen that I have introduced about the force and what are the types of the force. Just recall the topics and we will moving about the Newton's law of motion. Firstly, we have seen that what the force is, right? We say that the force is a push or a pull action. In an easy way, we used to say this. But whether the force is only the push or the pull action? No. But it is of different actions that have been done on the object. So we can say that force is an external effect or the external effort done by the external agent on the body. And there will be some changes in the body. So it is an action word. So force is an action word. And it can be of any action that can be change the size, shape, motion or the direction of an object. So like example, we have seen various actions in our daily life like lifting, pushing, pulling, stretching, compressing, twisting. This all used to be done on object due to which the size and the shape or direction may change of that object. So this is the external effect which is said to be the force. And we have seen that what are the effects of the forces, that whenever the force is applied on any object, there are some changes. What are the changes? That force can change the state of rest or the state of the motion. The force can move a stationary body. The force can stop a moving body, right? Because so force can even change the state of rest or change the state of motion. It can even change the speed of a moving body, because if we apply a force to a moving body itself which is already moving, if we apply the more force to that object, then it will start moving with a extra speed. So we can change the speed of that object. And if we are changing this direction, like if our ball is moving straight and we want to make it to ourselves, we have to change the direction to ourselves. Then if we touch that object with greater force, then it will move towards us. So this how we change the direction of the body. We can change the shape and the size, like on pressing the chapatis in the home, we used to change the shape of it, right? Or by pressing the clay, you can change different shapes and you can give different shapes to that clay. So this is how we change the direction, shape, size. Moving a body, we can make it rest, or a rest in the body, we can change the speed and make it in a motion. So these are the things which a force can change. And after that, we have seen that force are mainly of two types, that is contact and the non-contact force. Contact, due to which we are in contact with that object and we have to change the state or the rest or the state of the motion. But without contact, we can also apply the force, and that is said to be the non-contact force. What are the examples of contact? Like muscular force. If we have to press or stretch a body, we have to touch that body and we have to use the power of our muscles. So we can say this as a muscular force. So we have to use this muscular force by touching that body or by in the contact of that body. So that is said to be the contact force. And the non-contact, which can be done without the contact or without touching, like if we apply a magnetic force on a body, like we have an iron nail and we bring it towards the magnet, then it get attracted towards the magnet without touching, because we don't give it a contact. It just move from that distance to come to the magnet. Okay, so this is the effects of the forces and the types of the force. And after that, we are going to see two different types of forces, that is balanced and unbalanced force. Last time only I said that the balanced force allow the body to change not the rest of the positions, right? It only changes the size and the shape. It does not change the rest or the motion of a body. We know that force, if it is balanced, then the resultant force should be zero. That is, the direction may be different, but the equal and the opposite forces should act on that body. And if these balanced force acts on a body, then the balanced or the resultant or the net force towards the whole body is said to be zero. And if the force is zero, then the body cannot be moved, because if some force is allowed to be extra and the force is less, then the body will be moving towards the extra force, because we are applying the extra force on that object. So now this force is unbalanced. So unbalanced force is allow the body to move. So we can say that the balanced force does not allow the body to move, or a moving body cannot be stopped. But the unbalanced force can change the state of motion of a body. But no, unbalanced force is applied on a body, then body is able to move. If the balanced force is applied on a body, then it changes the state of the size or the shape. We can say that it does not change the state of rest or the motion, but it changes the size and the shape. If we just press a balloon, then we cannot make it move, right? It just changes the size and the shape. Same wise, if we apply an unbalanced force and we try to stretch a body or we try to twist a body, then it just changes the motion also. So here the resultant force is not 0, but there the resultant force is 0 in the balanced force. So these are the balanced and the unbalanced force. This is we already learned, that's why I am not telling you in the detail. But now we have to read here in this session about the Newton's law of motion. So whenever a body is moving, then we know that it is moving due to the some external force, because whenever the external force is applied on the body, then only the body starts moving. So this is a force, and this moving body is said to possess the motion. So motion is a property of a moving body, or we can say that the moving body is said to be in motion. So this is the nature of a body. But this moving body have some laws, and these laws were told by some scientists. Firstly, Aristotle told that he was the first scientist who told about a moving body. He told that whenever a body is to be moved or to be in the state of rest or state of motion, then some external force should be applied. This is the first law given by the Aristotle. But after that, Galileo came and he told that this experiment to be proved wrong. He said that this statement was wrong because to apply any force there should be some opposing force on an object. Every object has some force, that maybe its weight or the gravitational force or any kind of balanced forces. Then we are applying a force more than that opposing force. So any external force acting on the object should be more than that of the opposing force. Then only we can change the state of rest or the change of motion. Similarly, Newton after this he told that whenever body is at the state of rest or to be in the state of motion, then some external force should be applied on the body so that the body can move. So this was the law of the Newton. So he told it first. So this is a Newton's first law. So what he told that Newton's first law, that whenever a body is rest, then it will remain at rest. And if the body is at in motion, then it will continue its motion until or unless it is exerted by some external force. So whenever an external force is applied on a body, then its state of rest or the state of motion is changed. So this was the first law. This law is also known as law of inertia because he defined inertia word through this first law. What he told that whenever a body is at rest, it tries to be in the rest, and if it is in motion, then it tries to continue in the motion. So this is the tendency of a body to remain at rest or remain at motion. This tendency is said to be the inertia. So the first law always tells the law of inertia. So inertia law is a law of first motion. So Newton's told that the tendency of a body is there to remain at rest or remain at motion. So it will continue to be in motion, or if it is in rest, then it continue to be in rest. This is the inertia. But whenever we apply a force, we can change the state from the rest to motion or from motion to rest. And these external force is applied on the body. So we can say that the body at rest will continue its rest, and if a body is in motion, then it will continue in motion until or unless an external force is applied on the body. So he told both the things, that inertia was defined, and he told the law of first motion. Okay, first law of motion, or the Newton's first law of motion. Got it? And from here he told what the inertia of rest is and what the inertia of motion is. Whenever the body is at rest, if we apply some force, then the body tries to be in the motion, but it cannot be bring into the motion suddenly, because we are applying that force and we are trying to make it suddenly to its motion, so it cannot be changed. So we can say that the inertia of rest is that whenever a body is at rest, it cannot be moved into the motion. So this is the inertia of rest, and if the body is in motion, it cannot be bring into rest suddenly, it have to take time. So it will tendency of the body or the property of the body to remain at motion. Whenever a body is allowed to be come into the motion, then it is said to be the inertia of motion. For example, we have seen that whenever we be in the bus or in the train, then the body is allowed to move when it start moving. Like if you are sitting in a train and suddenly the body or the train starts moving, what our body does, whenever the body starts or a train starts, then our body moves backward, we get a backward jerk, right? Or you're standing on a bus also, then also you get a jerk in the backward direction. What does it mean? That the lower part of our body, that is the legs, are in the state of the rest along with the train. But as it starts the motion, our leg also moves with the train, right? So lower part is in the motion now along with the train, but the upper part is also now in the rest itself, because it is in the tendency to be in the rest. So as the train starts moving forward, the body move backward because it is in the rest position, but our legs are moving forward because it is in the motion along with the train. So this state of rest and the motion are together happening with our body, so we get a jerk in the backward direction because our body, that is the lower part of our body, legs, are moving in the motion, but our upper part of the body still remain in the rest. So this is the inertia of the rest. And similarly, when our body is in the motion, when our train is moving along with us, our body is also in the motion. But suddenly when the station comes, the train used to be stopped. And when this train used to be stopped, our body, that is the lower part of our body, is bring to be rest along with the train. But the upper part of our body is still in the motion, so it will moving with the motion that is in the upper direction. So our body will be moving in the forward direction because the motion is in the forward direction. Now our body is also tend to be set in the forward direction. But whenever the train stops, we come in the jerk in the forward motion. So we are getting a jerk in the forward direction because our body is still in the motion, but the lower part of the body are get into the rest. This is the inertia of the motion. There are many more examples. If you read throughout the book, you will get more better, because we cannot take the time throughout one video to tell about the examples, and many more are there. If you think of a game that a coin is placed on the paper and that paper is to be placed on the glass, and we have to put that coin into the glass, then we just have to slip the paper. If we take it time, then the body will try to make it in the motion itself. So we have to make that body to move, but in a sudden shape, because if you take it in sudden time, then the body will not understand that it have to be in the motion or it have to be in the rest. So if the paper coin is placed, then the paper is used to be slipped out from there. Now the paper is in motion, but the coin does not allow itself to move in the motion with the paper, so it will remain in rest itself. So it can move in the glass also, so it can fall in glass. This was the game. You can see the game. If it takes a time to remove the paper, then the body cannot fall in the glass. If you take out suddenly, the body cannot make it tend to in the motion, so it will fall in the glass. So these are the inertia, and these are the applications of the Newton's first law also, you can see, because Newton's first law is just a law of inertia itself. So he just defined about the inertia. He just told about the force also, and he told that whenever body to be in the rest or in the motion, the force should be, external force should be applied on that body. Okay. So before going to the Newton's second law of motion, we will be seeing what the momentum is. So what is momentum? Momentum can be defined as the property of a moving body. You can say this is a property or the impact of the force on the moving body. So this is kind of an impact, but how can we define that? Momentum is just a quantity of the motion in a body which depends on the mass and the velocity. It can be defined as a product of and the mass of the velocity of the body. So it is product of mass and the velocity of the body, which can be given by m into v. So every body possesses momentum. Every body has the momentum because it is the impact of force, and every body is with a balanced or the unbalanced force, but it is always exerted by a force. So every body will have the momentum, and momentum is denoted by the letter P, which is equal to the product of the mass and the velocity. So it is given by P is equals to m into v. So we can say that the force is directly proportional to its mass. It is directly proportional to its velocity also, because we have seen in the effect of the force that whenever the force is exerted on the object, we can change the velocity of the object. So force is directly proportional to its velocity, because if we are applying more force to an object, then the velocity of the object will also increase. So both are directly proportional. Similarly, a force is more required for a heavy mass, right? If it's a large body and we have a heavy mass, then the more force is required to move that object. And if the object is of less mass, then the less force is required to move that object. So force is directly proportional to its mass also. So what we can say that the product of mass and velocity is equals to momentum. So we can say that the momentum is equals to m into v. So we can say that p is equals to m into v. But we know that force is directly proportional to mass also. If mass is gaining of a body, that the heavy mass is there, then the force will also require large. And if force is directly proportional to velocity also, because if we change the velocity of a moving body, then we can apply the more force to make the direction or the velocity to be changed. So force is directly proportional to mass also, and force is directly proportional to velocity also. If we take this both together, then mv. So force is directly proportional to mv. This mv is equals to momentum also. So what we can say that force is directly proportional to momentum also, but the rate of change of momentum. What does it mean? That the momentum change in a body with the time is directly proportional to the force. So force is directly proportional to dp by dt. What does that mean? That the average momentum and average time. So we can write it as p upon t also, that is rate of change of momentum with respect to time. So p is the momentum and t is the time. So force is directly proportional to the rate of the change of momentum with respect to time. Okay, so this itself is used in the second law of motion also, but here we have seen what the momentum is. Momentum is equals to mass into velocity. So here if we take the relation between mass and velocity, then mass is inversely proportional to velocity and velocity is inversely proportional to mass. How can we explain it? Right, if we are having a body of a mass 50 kg, you can just make a body move easily? No. Why? Because you cannot move that body easily because it have large mass. So velocity will be very less to move that body. If you are having a body with 2 kg, we can just throw that body easily, and body can have a large velocity also. So body having a large mass will have the less velocity, and if a body having a less mass then can have the velocity more. So both are inversely proportional. And we say that every body possesses momentum, every body has momentum. So P will be there because mass and velocity is there. So every body will have mass. So mass cannot be 0 because we have read this in gravitation also, that mass cannot be 0 but weight can be 0. So mass cannot be 0. So what is the value for the momentum to be 0? The velocity should be 0. Right? Velocity should be 0. Velocity should be equals to 0. Then only we can say that the momentum is 0. So momentum cannot be 0 of a moving body, because for a moving body velocity is always there. Velocity cannot be 0 for a moving body. So momentum cannot also be 0 for a moving body. But if the body is at rest, the mass is there and velocity is also 0. So velocity will be 0. And if one of the value of m or v is 0, then momentum will also be 0. What does it mean? That the momentum of a moving body is always there, but the momentum of a rest body will be 0. So this is what the momentum is. Momentum is the impact of the force on a moving body. Right? So if we see an example, that if we allow to move a moving body, the momentum is considered to be the measure of the quantity of motion, right? That how it is moving. If you are exerting a force, then it starts moving. Then the moving body will possess some momentum. Then how can we measure it? So we can say that is the impact of the force or the measure of the quantity of the motion of a body, that how it is moving. Okay, so that we can see that how it is moving. See this example, that there are the piles of the tiles, that is very much tiles are there one upon each other, that is kept. And if we have to, karate player is allowed to broke this tiles, then he just allowed to break one tile, and together the whole the tiles are used to be broke, right? You can see it in India's Got Talent also, and many other programs you have seen in the TVs, that persons used to just blow his hand on the first tile or in the first tube light or in the first brick. You have seen many examples that you just allowed to move your hand or blow a hand in the first part, then the whole the parts that is kept with each other are kept to be broke, right? How it just happened? Because the momentum of that hand will be more if you are applying the mass, because masses cannot be 0. So velocity should be of the large value. If the velocity is increased to a large value, it is allowed to blow the hand with a large velocity to that body, then the whole particle will be broke. Any particle, it can be tube light or bricks or the stones or the piles of the tiles, it can be break. So we can say that the momentum of that body is increased, so that velocity should be more, because mass of body cannot be changed, but velocity can be changed. So if there is a high speed, then we can just change the direction as well as the momentum of the body. And here this is an example, and many more are there, because if the body is thrown with a high momentum, then it can hurt the other body, because there will be some force also. And if the momentum is there of high, with like a truck is done an accident with some other body, if it is accident with a car or with an cycle, so cycle and car are having the less mass, so momentum will be less, but the momentum of truck is high, so the accident will be a worse condition, because the truck can just hit that body with a large force or the large momentum, right? So these are the examples of the momentum and the force. So here a sample problem is there, that what is the momentum of a man of mass 75 kg when he walks with a uniform velocity of 2 meter per second. So mass and velocity is given. What is momentum? Product of mass and velocity. If we just multiply this mass to the velocity of that man's body, then we can find the momentum of the body. But remember that the momentum is given by the kg meter per second. This is the unit. So we can say that the velocity should be in meter per second and the mass should be in kg. So if it is given in gram or kilometer per hour, you have to change it. Okay. So secondly, we are going to see what the Newton's second law of motion is. What the second law of motion tells us, that the rate of change of momentum of a body is directly proportional to the force applied on it, right? So what that means, the force is directly proportional to the rate of change of momentum with respect to time. So first line here you can see that force is equals to change in momentum upon time taken. Now what is momentum? Mass into velocity. If there is some change in the momentum, then we can say that the body with the initial velocity at the starting point, some momentum is there and now the momentum is changed. So let the velocity of the initial body be u and the velocity of the final product will be v. So what it can be written as the initial momentum be mu and the final momentum can be given as mv. So the difference of the momentum can be given as mv minus mu. So if you take m as common, then it will be v minus u upon t. And what does v minus u upon t tells us about? That is the rate of the change of the velocity with respect to time is given by the acceleration. So what force can be given as mass into acceleration? So from here the second law, he told about the force, he told about the quantity of the momentum, impact of the force, and what the formula for the force is. What is the formula for the forces? Force is equals to mass into acceleration. So what is the unit of the acceleration? It is meter per second square. And what is the unit of mass? It is kg. So kg meter per second square, it is the unit of force. So it is the unit which is given as the Newton. It is the SI unit. If you talk about the CGS unit, then it will be dyne. So force is equals to mass into acceleration. It was given by the Newton's second law of motion. Now we are talking about the Newton's third law of motion. What it tells about, what is the statement? That every action has an equal and the opposite reaction to every body. So this is the Newton's third law of motion. And what does it mean? We are talking about the force, because a moving body will have the force. So force exerted from the first object to the second object, then the second object will also be applied. The force on the first object will be of the same magnitude. So the same value of the force will be getting in the back direction. So we can say that when we apply a force on any object, and when we get back the force of the same value on us also, but the force will be equal magnitude, but the direction will be opposite. So we can say that the equal and the opposite force will be acting on that object. So Newton's third law of the motion tells us that every action has an equal and the opposite reaction. For example, you are stretching a spring with some force and you are allowed to leave it, then what it will do? It will come back or jerk back with the same force. So whatever the action will be, the reaction will be same. Like if you are having a rubber band and you just try to stretch it in your hand, you just have the rubber in your hand, and if you stretch it with some force and you leave it, you get hurted, because the force will also be the same with which you have stretched it. If you give a small stretch, then the force will also be less and you will not get more hurt. So this is the every action has an equal and the opposite reaction, or we are applying a force to any object, and we will get back the equal magnitude of force by that object on us. So here we have seen the three laws of motion. That first law, what it tells, that whenever a body is in rest, then it continues its rest position, and if it is in motion, then it will continue its motion until or unless it is exerted by a external force. And what the Newton's second law was, that force is directly proportional to the momentum with respect to the time. So every body possesses momentum. We have read about momentum also. What the momentum is? It is the impact of the force or the quality of the measure of the motion of a body. That how the motion is. It depends on the mass and the velocity of the body. So it can be given as mass into velocity. And we have seen the third law also, that every action has an equal and the opposite reaction. If we apply a force on any body, then that body will apply the same and the equal forces on us, but in the opposite direction. So these were the three laws of motion. We will be seeing the numerical related to this laws of motion in the next session. So thank you class, and try to revise your chapters 2 so that you can get better with the term 1, so that you can be revised to the term 1 also, because on 27 September you will be getting started with the term 1. So try to make it time and try to make a timetable so that you can get through the 3 of the subjects, bio, physics and the chemistry. Okay. So thank you class, and if you have any queries you can just ask me.